Well, hello guys, Mr. G here, and we are going to be doing lesson 7. Now, lesson 7 is going to be revision on conservation of momentum, which was last lesson. Please, you can go there and watch the video. Now, we're going to be solving two questions. The two questions are going to be on the description. You can go there and try to solve the question before I solve it, and then use the video as a mark guideline. Okay, so that is my recommendation. Now, the question 1 said a block A with a mass of 4 kilograms moving at the velocity of 3 meters per second to the right collide with a stationary block B with a mass of 2 kilograms. After the collision, the two blocks stick together and they move on. Calculate the velocity of the two blocks immediately after the collision and ignore the effect of friction. Remember, since the moment they said here, ignore the effect of friction, that means that the system is closed. So this is a closed system. This is a closed system and you have it there. Now, we're going to do the following. We are going to complete the data of the question, but on the picture. The picture is given to you, but if it was not given, please, I recommend you highly to do the picture because it will help you. We have a before collision and we have an after collision. So let's start answering, and before that one, because it is a closed system, we know that the total change in momentum is going to be equal to 0, and that means that the total momentum initial is equal to the total momentum final. Let's write the vector symbol there. Now, we have two blocks, so the total initial momentum will be the initial momentum of block A plus the initial momentum of block B, and this is equal to final momentum of block A plus the final momentum of block B. Okay, and the vector symbol, let's edit them. Now remember, the momentum is equal to the product of mass and velocity for each block. Alright, and we are going to substitute in each of the cases there. So we are going now here, I'm going to move it a little bit. There we have mass of block A multiplied by the initial velocity of block A plus mass of block B multiplied by the initial velocity of block B is equal to mass of block A multiplied by the final velocity of block A plus mass of block B multiplied by the final velocity of block B. So that is what we have, and then the rest of the question is just the substitution. I will substitute and I'll show you just now. And here we have the substitution. Now note the following. At the initial, we have that this side here is going to be equal to 0 because the initial velocity of B is 0. And on this stream here, I recommend you to substitute before to do the math, but you can do it as you want. It's not a big difference. I recommend you because you get marked for substitution. So then here, velocity A and B is the same because they are moving together. So using math, that will be the final velocity of both of them. It's a common factor, it's mathematics, 4 plus 2, and there on the left hand side we have 4 times 7, which is 12. So this is what you have, and if you finish this question, then you will have that the final velocity will be 12 divided by 6, and the answer is going to be 2 meters per second. Now let's go back quickly to the question. They said calculate the velocity of the two blocks. Now velocity is a vector quantity and therefore it has direction, so the final velocity is equal to 2 meters per second to the right. How do I know it's to the right? Because I say right is positive and the final answer is positive. So this is the final answer for the first question. I hope you understand. It's quite easy. Let's go and look at the second question we're going to do. Remember, we're going to do only 2 questions in this lesson. We're not going to do more questions, only 2. Now question 2 said everyday accidents take place in the road of our country. Modern cars have crumple zone, seat belts and airbags to reduce the risk of death or injury. When I did the lesson, so you can go to that lesson and check how to explain the side of crumple zone and airbags and so on. Now, in one of these collisions, a car of mass 2000 kilograms traveling at 28 meters per second to the left collide head-on with a minibus of mass 3500 kilograms at 18 meters per second to the right. Okay? After the collision, both vehicles move together as a unit in a straight line. And they don't say it here, but we are going to set ignore the effect of friction, and this one will make the system to be closed. Okay, so now here is the picture. You have a minibus and you have a car. The minibus is moving to the right, so let's just add the data as we did previously here. Now 2.1, calculate the velocity of the system formed by the car and the minibus, exactly the same as the previous question. And 2.2, use the principle of physics to explain how, and let's fix that word quickly, there we are, how airbags can reduce the risk of injury or death. So that is the thing, and we're going to start answering this question. First of all, I'm going to redo the picture real fast. Alright, so here is the picture with all the data and more or less what is happening. In the beginning, we have a minibus that is moving to the right and a car which is moving to the left. They're going to have a collision here and after, and then obviously they're going to move together. I didn't write direction because we have to get out also the direction. Okay, so now here, before we carry on, we are going to select what direction is going to be positive, and we are going to do right as positive. Remember, this is entirely up to you. You are deciding what direction you want as positive, and any direction will be the same. So in this case, we say to the right is positive, and we are going to use the principle of conservation of linear momentum. If the right is positive, that means that the velocity of the car is going to be negative because it's to the left, and velocity of the minibus is positive. So if we substitute here, we have 3500, which is the mass of the minibus, multiplied by the velocity of the minibus, plus 2000, which is the mass of the car, multiplied by the initial velocity of the car, which is negative because it's to the left. So the rest of this one is just the calculation. The next question says, use principle of physics to explain how airbags can reduce the risk of injury or death. Now, if we remember or recall Newton's second law in terms of momentum, which I'm going to write down here real fast, we say that F net is equal to the rate of change in momentum. So this was the law. And remember, we said that if change in momentum is constant, for the same change in momentum, this is constant. For the same change in momentum, if this one decrease, then the force will increase and will be very big. Or the other way around, if the time increases, then the force will decrease. And this is in actual fact what happened here. So let's write the answer. So the answer will be as following. When airbag inflates during the collision or a collision, the contact time, this is important, contact time of the passenger driver with the airbag is longer than without it, and thus the force on the passenger is reduced for the same change in momentum, and that is according to the law, which is right here on top. So that my lovely people, children, learners, is all for this question. I hope it helped. I hope you understand there are two questions. Next time we're going to be doing another two questions related to conservation of momentum. It's a very important topic, and perhaps we'll practice some Newton's second law in terms of momentum before we go to the last part of this topic. But thank you for watching. Thumb up, subscribe for the channel. I'll see you next time.